I'll go ahead and share my screen. 1 second. Great. Can everyone see the meeting notes here? Awesome. All right, welcome to our July 6th developer meeting. We have this every first Tuesday of the month, and we have a few items on the agenda today. But to start off, just some announcements. Akri is going to be a part of Open Source Day at Grace Hopper Celebration this year. That's in late September. I don't remember the exact dates off the top of my head, but if you're going as a participant or as an ally, it would be great to stop in. And for Open Source Day, I believe they accept mentors, so you can help some of the attendees check off some of Akri's issues. And prior to that event, we're going to be sure that we have enough issues that are marked as good first issues and have enough description on them, so that oftentimes the attendees are still starting along their CS trajectory. So having some really good descriptive issues there will be helpful to launch people into open source development. So that's exciting, and having that down the line is something we're looking forward to. Beyond that, we have several other agenda items. To start us off, we were going to talk about some development work and investigation we have with Akri and Webassembly. And for that, I can pass it off to Rods.
Hello, so we can get started with the presentation?
Yeah, go ahead. And 1 second, I'm going to go ahead and give you access. Awesome. So you can share your screen if you need to, Rods.
Awesome. Let me share it real quick. Can you see my screen?
Yes, we can see it.
Perfect. Yeah, so hello everyone. Good day, good morning. And yes, I will be presenting a little bit of my intern project that I have been doing here on Microsoft, and especially with involving Akri. And as Kate have presented, it's going to be Akri as a WebAssembly application. Yeah, first of all, it's a really weird name. It's a really weird technology like WebAssembly. And what does Akri have to do with WebAssembly? So let's start out talking about what is WebAssembly in general. And basically, it's a compiled target language that's going to be designed just to be more universal and can be deployed anywhere, and it's going to be running the same, and has a lot of good practice on the web, especially with on optimizations and security improvements. And on the web, is actually increasing really quickly, and we can see a lot of good developing going on there. But for our case, we're not going to be talking about the web. We're going to be talking about a new subset of WebAssembly that's called WASI, which is the WebAssembly Systems Interface, that actually is being built to be running WebAssembly outside of the web. So we can run it on the cloud or in a server. And yeah, it's WebAssembly running outside of the web. It's kind of a weird name, but it's really going to be improving, and we can see a lot of the improvements that WebAssembly had on the web being brought to the server. So yeah, it's really fun. And okay, so now what Akri has to do with it? First of all, I need to introduce the Crustlet project. That's also a Dayslide project that pretty much allows you to run WebAssembly workloads inside Kubernetes, because of course WebAssembly is not something that's going to be natively going to run on Kubernetes. So the Crustlet teams and the Crustlet project really is really awesome to help do that. And it does that by replacing the Kubernetes kubelet. It creates a new kubelet in a new node, and it then allows you to run Kubernetes WebAssembly workloads on Kubernetes. And this is what we're going to be doing, since we're going to be using Akri inside Kubernetes too. And of course, what does Akri have to do with it? So as I mentioned, WebAssembly is bringing out a lot of different improvements to the cloud. So in terms of code size, since the compiled code for WebAssembly is really small, on Akri's case, on a particular discovery handler, we saw a pretty much 90% decrease on compiled file size, which is really important since on Akri we are dealing with edge technology. So on the edge, we don't have a lot of powerful machines. So any improvements we had on this subject is really awesome for the project, and this is what we're going to be trying to achieve on this during this development. Yeah, but yeah, not everything is so great about WebAssembly, since kind of like a new technology. We can see a lot of things that are limiting us, and of course, some of them is just because it's since a new technology, people are already working on solving this and are already working on improving it. And so in the future, we might not even come across these problems, but for now, this is the situation we have. And so the first thing is that WebAssembly is single-threaded, so we cannot do a lot of asynchronous and multi-threading activities. This is used a lot during Akri, and of course, on the other topics, it's used a lot on gRPCs or HTTP servers, since of course we need to do multi-threading to being able to handle multiple requests at the same time. And another limitation is that Akri has a limited network component. So for example, it doesn't have access to sockets for now. This is something that's pretty much going to be soon going to be integrated into the project, but for now it cannot do any sockets activities on there. And of course, we cannot create HTTP servers using WebAssembly, and Akri uses a lot of gRPC servers. So it's kind of like a scratch inside a scratch. So it's really hard to create a new gRPC server inside WebAssembly. So yeah, these are the limitations we have right now. And what we came to handle in like on a workaround these limitations, we are getting this designing how do I say, template. And of course, we've started on debug echo discovery handler. So we kind of like started to building up from there. So we started on the discovery handler and try to see the limitation we had there. So what how we managed to run a debug echo discovery handler inside Kubernetes, inside the Akri Kubernetes, is introduced the Grpc Proxy, which pretty much handles the connection between the WebAssembly module and the Akri agent. So of course, as I said, the WebAssembly cannot host a gRPC server. So we're doing this only using files, input and output files. So the gRPC proxy is responsible to connecting with the agent and then sending the input files to the debug echo so it can process and discover the devices. And the debug echo brings to the output file, then the gRPC proxy reads it and sends to the agent, and then the agent can do what he needs to do. So he can create the devices, see the device started being discovered, and then can move on to the other applications. And a good thing to notice is that for now on this part, we can only see the debug echo, the discovery handler running on WASM. The other parts are still running on a container, a normal container. In fact, the Akri agent here is the exact same Akri agent that currently is running on Akri. So we didn't have any changes. We didn't need to change anything on that for this part. So yeah, talking more about what we have right now. This is the design how the infrastructure is based on. So of course we have on the left part, we have all the things that's running on a kubelet node. So a normal Kubernetes node, which of course are Akri, the grpc proxy. We can see that the broker pods that are still being deployed into the normal kubelet. And on the left, on the other side, on the right side, we can see everything that's running on a Crustlet node. So of course here we only have our debug echo running, which is the discovery handler. And then we have our input and output files, which is running on the same VM as both of them. And then it can handle the communication between them, and the whole flow can go on. And yeah, so what about the next steps? Because of course we have a discovery handler working, and it's kind of like we have seen a lot of progress, but we're still going to be doing like a lot of design and a lot of discovery to see what could we work on right now. So of course, the first thing would be Crosslet using Akri devices, because as I showed on the previous slide, on the kubelet is actually in fact using the devices. So the Crosslet node doesn't in fact know about the devices yet. So a good thing would be adding these devices to the kubelet node so we can deploy a WebAssembly application or module that requests the devices and use the devices inside them. So yeah, this is going to be something that we plan to doing. And of course, the other part is, which is actually really harder, which is trying to make the Akri agent running as a WebAssembly WASM-WASI application. And of course, this would be kind of like creating the whole flow. So the whole Akri flow will be running as a WebAssembly module. So all the connection part, all the device creating would be running inside the Crosslet node. And of course, we still, even if we bring the Akri agent to the Crosslet, there is going to be still a lot of limitations. So we're probably going to be needing a new Grpc proxy to handle the connection between the controller and the Akri agent and so on. So yeah, this is of course really a work in progress that we're still trying to see what we can go on about it on the next type of the project. And yeah, thanks so much. Yeah, that was it. I think I was really fast, but as I can see, I have everything coded on the GitHub that I can link on, that is linked on the slide. And yeah, everything that we're going to be working during this internship will be there with the demos and so on. So you can check it out and comment out whatever if any of you guys have any ideas or suggestions. And yeah, any questions? Okay, so I will pass on back to Kate, and thanks so much.
Thanks, Rods. Really cool to hear all the work that you've been doing. And I think a big part of this, like you mentioned, was how Akri is already made for those edge environments. And then compiling our components as WebAssembly modules will decrease the footprint of Akri even further. And being a part of this really up and coming technology is a pretty exciting process. So it's been fun to see all the things that you've been learning through it. Let's go ahead and go back to the agenda. Up next, we have some further discussion on Mqtt. And for that, I will pass it over to Shan.
Hello, everyone. Sorry for the delay. So we're back to Mqtt with the discussions that's been currently available on the PR that I've created, at least in terms of the proposal. Thanks, first of all, thanks to Kate and Brian for putting out some important questions that actually need to be clarified when it comes to bringing Mqtt to Akri. I've tried my best to start to resolve the whole questions that have been posted in the PR. So if Kate, do you want to share the PR, or should I share my screen to just show the PR?
I can go ahead and give you access to share it. That way you have control over how it's sorry, one second. Oh wait, I don't think I can. I think Rods may need to give you access. One second, let me try real quick. Anyways, here, Rods, do you know if you can try and share?
Yeah, I think I can. I think I've got.
Oh, you got it?
Yeah, I put the option to multiple participants can share the screen, so I guess this works.
Okay, thanks.
Yeah, So I hope you guys are able to see my screen.
I think it's still
second.
loading.
Yeah.
Oh,
All right. So just a heads up, this is the pull request that's out there on the repository. I've tried my best to, for example, summarize what MQTT as a protocol is. That's the general gist that usually begins with the proposal, and then how from my personal perspective, probably Akri might be able to help. Of course, coming in with just basic knowledge about what Akri provides, that's what the review process is right now. So there are lots of questions that have been posed, and I've tried my best to answer some of the things. So what I generally found out from even at looking at the co-op proposal that Giovanni actually has created, it seems like I think MQTT in general, the pub/sub mechanism in general is quite a different paradigm when it comes to understanding how does one actually request resources, so to say, quote unquote resources, or how do you get some idea behind it? Like how does that happen? In most cases, I think even in the co-op proposal, I found out that it's usually when you ask, when let's say when a software entity asks some server to provide some feed, to provide some resources, and then you get the response back. However, I think in MQTT it's quite different, where you go in with an assumption stating that, for example, that there are resources out there that are able to publish something on MQTT topics, so which are string-based topics. And for example, and then you as a developer are pretty much aware that by subscribing on a particular MQTT topic, you will be able to get the information back. So I've been going through a lot of, I've been going deep diving into the specification documents as, and I've been trying to answer questions as much as possible. For example, one of the really interesting questions that I came across from Kate was how do MQTT clients normally respond to topics no longer being published? So the thing is, MQTT bases itself on completely on the networking aspects and the transport layer aspects of the IP stack. So that means it does not concern itself whether the clients are publishing data or if there's data actually coming in on the published topics, right? So chances are, even if you are subscribed to a particular topic, if something goes haywire in the firmware of your IoT device, and if it's not publishing, there's no way of proactively saying, okay, I think I've been trying to listen for the past 1.5 hours on this topic and as nothing has come in, so I might as well disconnect. There's no such thing as that. However, there are mechanisms in MQTT, for example, where I'll just show you through the drafts, where you can actually disconnect from the system or from the broker just by realizing that someone was trying to, for example, publish, someone was still publishing some information, and now there was some sudden abrupt network loss, and then based on that, the MQTT broker as an entity has something called as the last will and testament concept. So that can be used as a way for the Akri monitoring broker to decide, okay, it's time, I think we need to strip down the application that's running behind the whole monitoring aspects of it. So I was able to document that. So for example, this one, number B, optional last will and testament, it generally is a practice where if let's say if you have a temperature sensor that can talk MQTT at the transport layer, so it will try to, for example, before establishing a connection, it will try to say, okay, if my connection loses to the broker, this is my last message that the broker is responsible for sharing it ahead to the people, to the, let's say, the applications that are subscribed to that particular topic. So maybe that's one way of answering the question. There's another VEEF MQTT specification, which is the version 5. So I've been going through that. There are certain changes there, but it's highly unlikely that it's a massive breaking change that for example can answer this question directly that was posed by Kate. So for example, there's no, at this point of time, I can confidently say there's no way of saying whether if the MQTT client is pretty much aware whether there's no data coming in or not. So it will try to maintain the connection as long as there is a network connectivity there. And if something breaks, then it breaks. That's how it works usually in the case.
Sorry, just a question with this, a follow-up.
Yeah.
So that makes sense to use that last will and testament in some aspect. And I guess what the question here is that I'm not concerned with the client handling a topic going away, but more so with the discovery handler handling it. So if the discovery handler is polling the broker to see what topics are available, so that then you can deploy your custom brokers to utilize those advertised topics. What happens when the discovery handler sees that this topic no longer exists, takes down that resource, if this is the scenario, which then the controller will take down that client? Like, I think so my question was, is that a normal flow for a client to be brought down when its associated topic is no longer advertised?
Well, that's the point. The interesting thing about MQTT in general is there's no way to know a priori if there's a topic already being published on the broker. So if there's someone publishing on a topic, you as let's say the developer at the other end who's willing to consume that information has to know the topic a priori. So there's no way that, for example, one can determine by polling the broker or something, where finding out certain statistics, whether, let's say, temperature/sensor/1 is a topic that's available on the broker in itself. It's only when a publishing client and a subscribing client have the same, let's say, topic, then the whole chain gets filled in. Apart from that, there's no way of determining if a certain broker has certain topics already being published on it. It's quite different from other messaging brokers such as Kafka, maybe even the AMQP parts or something, but it's very rare that I've tried going through a lot of open source brokers as well as proprietary ones. It's very rare to find out which topic is already on the broker beforehand.
Yeah, and I think in a way Akri provides that awareness, because the client will only live so long as that topic is there, if that is the scenario. But I guess taking a step back, kind of going to Brian's comment on the PR, what do you see as like the prevailing benefit of using Akri? I think that's what really would be great to nail down in this proposal.
Right. So we've been thinking about this, like I think I've previously mentioned it in the last call, but the way that I see Akri is a way of, let's say, dynamically scheduling some form of application that pretty much, let's say, reflects on how you guys have developed the on-whiff camera concept, right? If you plug in a new camera, then for example, you have some application that spins up based on a new camera being introduced. That makes complete sense when you have an edge device that can be that is able to, for example, talk to an on-whiff camera. But over here, there's always this level of abstraction, which is like the broker in itself. So we see it in a way which is quite interesting. You can use the MQTT topics in a way. So instead of just being like just subscribing to a fixed MQTT topic, we can use some wildcard entities like plus or the pound symbol that's already in the documentation, and you can then determine, okay, today, like let's say I've introduced a new temperature sensor, and tomorrow 10 more sensors are being introduced on that particular topic. So based on that, you can spin up, for example, some form of monitoring pods, or maybe even some form of let's say data analysis pods based on newly introduced sensors, without having to go all the way to the edge device and trying to, let's say, spin up a pod, or maybe try to spin up a container based on some new sensor that has been deployed. So I see it as like a dynamic flow of like dynamic application that gets triggered once new components start to come into that MQTT subsystem environment, so to say. That's how I visualize it. So in our case, like for example, since the research I'm doing is pretty pretty dominated by the MQTT protocol. We have a system downstairs where we have ultra wideband location tags, right? So a person in an industry can work very close to a robotic heavy lifting, heavy work payload robot. And it becomes quite critical where you want to make sure that the robotic arm movement and the movement of the human that is within that work vicinity, it needs to be tracked in a certain safe way where you can decide if the person is unwillingly, for example, going towards the robot or has no idea where that motion is. So you can stop that robotic arm in a situation where let's say if something hazardous is bound to happen. So for example, if the robotic arm speed is very high and the person is walking towards that robotic arm, you can actually trigger some form of mechanisms that can stop the robot or maybe even slow the speed of the robot based on how the location of the person is. We have a system over here in-house which actually does this by providing information via an MQTT broker. So there are specific topics that we have that we want to, for example, subscribe to, and then figure out, run some algorithms behind the number of people that are coming into this workspace, and then you can then spin up some applications based on this. And I thought since I went through a lot of videos on YouTube regarding the Akri presentation, I was thinking in the lines of, okay, this may be very similar to, let's say, plugging in a new USB camera or something like that, and a new person coming into the workspace implies that there is a sensor that is, for example, publishing information on a specific MQTT topic, which can be subscribed by Akri, and then based on that particular topic, it can spin up some form of monitoring or some form of application that can run that kind of things. So I think if I wanted to answer Brian's question over here, which is this point, I think it's the second one probably might be the most interesting aspect, where you can bring the MQTT data to Kubernetes applications. That's how I at least figure it out. So right, if the problem also is the scalability factor. In fact, in an industry, it becomes very critical that if that you need to scale things at a very high level sometimes, and at very high speed. So it's very unlikely that someone's going to go to a factory, spend 1.5 days just trying to program everything on an edge device, and then come back and then realize the next day that there are 10 more devices need to be installed. So we assume that maybe Kubernetes on the edge, so the whole edge realm of Kubernetes probably might be able to do that for someone who's developing an industrial application in a very decent way, so to say. That's how we envision it, and that's why I've tried to bridge this gap for Akri and MQTT in that aspect. However, like I said, I'm very open to changes, and I'm still looking into different specs. If there are some things that we can answer these questions in a much more concrete way, I'm trying my best to try to figure things out so that it becomes easier for us to develop this solution. I hope I've made myself a bit more clear, or have I just babbled?
No, that was very helpful. It sounds like the key takeaway of this is it's almost like using Akri to dynamically respond to the MQTT broker and deploy
Correct.
workloads as a response to that.
Correct.
I think my follow-up question would be, a key part of Akri, and kind of why its acronym is a Kubernetes resource interface, is that the way that Akri advertises that it discovered something, or in this way responded to an MQTT broker, is by creating a resource to represent that. So then the follow-up question with this is, what is that resource in MQTT's scenario? Is that one topic? And we kind of, Giovanni probably can pitch in with this, because we had a similar discussion with Co-op in the sense that a single device is advertising multiple capabilities, whether that's temperature and light. In this case, we have a single broker that's advertising multiple capabilities, whether that's 10 sensors of one topic, or like all these different topics.
Right.
And so would each topic be a resource, or and what would your configuration look like? Those are some follow-up questions that.
Yeah, so I think, so this is exactly where the whole freedom of creating your own so to say application spec on MQTT falls apart really quickly, because you're free to do whatever the developer wishes to do, right? For example, so you can just create a topic name that is IoT, right? And then you can push as much data as possible on a single topic, or you can sit down and then design your own MQTT topics, which can make a distinction at a very deep level. So for example, you can start with a factory name, and then you can say /temperature. So only temperature data gets published on it with whatever metadata that's inside the payload to distinguish which sensor is producing this temperature data. Same logic can go for whatever other sensors or whatever other systems are being part of. So at this point of time, as a concrete answer, I would say each topic needs to be unique in its own aspect. So you cannot like, we can start with a very strict logic saying that each sensor or each actuator that needs to be introduced towards Akri is its own distinct resource, and with that it implies that it needs to be its own MQTT topic, so that it doesn't become very difficult for the, let's say, for the upper application layers to for example parse the information up towards the, let's say, the IT part of it rather than the OT part of it. So that's what I understand when you mention it over here, that each MQTT each MQTT topic is its own resource, and it's easier to handle it in that way. That's my understanding.
That makes sense. And then having a configuration where you're filtering by topic makes sense as well. And I think we kind of also in this PR have discussed a little bit about what discovery means in this case. And I think having all the things that we've discussed documented in this proposal, because like you responded in that comment, maybe discovery at first just means not discovery, rather like an aliveness check of like, this is where I think this MQTT broker is, find it, advertise its topics. But then maybe a VNext would be kind of doing a port scan, because you said there are standard ports that brokers live on, so that we can provide that as well. I've been asking a lot of questions though. Does anyone else have questions on this topic?
So yeah, I mean, just to add if no one else wants to answer the question or ask a question. So just to add on the last part of the discovery aspect of it. So there's a lot of intricacies out there, right? So since MQTT itself is a protocol that's been widely used, you can actually use standard ports to determine if let's say a broker is running. So which I've previously mentioned in this comment. However, that is also completely up to the user, right? So if your edge device is, let's say, somehow blocked for the development case where 1883 is not available on that edge device, but the user then has to, for example, configure an MQTT broker on that edge device on some other port, then chances are the Akri configuration might just have to use that particular designated port that is given by the user to let's say to subscribe to or to try to connect to that broker. So there are so many things, because I mean the great thing about MQTT is extremely flexible, but on the other hand, that's exactly the whole disadvantage, where everybody's free to do everything out there. It's not a IANA form of port, right? So I think in CoAP 5683 is a pretty standardized number, and it's been out there in the Internet Engineering Task Force that's been declared so and so. But in MQTT, I'm assuming it's not the case. You are free to choose whichever network ports you want to configure the broker to, and so on. And I was going through one of the proposals in Akri in itself, where there are certain proposals of other things like, Zigbee or LoRaWAN or something. So if you go down one more step from MQTT, which is like if you want to make sure that MQTT as a standard works for low power networks, which I think CoAP also does. I don't think it is a fact. There's something also called as MQTT SN, so MQTT for sensor networks. and they have concepts such as multicasting addresses where the client, so for example, Akri, the Akri implementation might also proactively be informed by such MQTT SN brokers where they say that, okay, on this multicast address, I have a broker that is running. However, there are lots of nits and pieces that need to be addressed when you try to go down to the low power network aspect of the whole MQTT protocol too. So yeah, so just a heads up, I've put some links there, so anyone who's curious enough to go through that is more than welcome to go through the specifications, and I'm also available to answer any further questions. Yeah.
Awesome. Thanks, Shan. Super helpful. And sorry,
I have a question. I raised my hand for not sure you saw that, Kate. So Shane, so I think you mentioned now that each device is going to be creating its own resource and its own topic, right? So can you walk us through the scenario when you plug in a new device? How would that work through Akri?
Okay, so chances are something like, I think I have something on my screen. I don't know if is the screen still available, still visible. I have a figure.
No, I only can see
okay.
the pull request.
Okay. Yeah, just a minute. Yeah, so I was talking to a colleague of mine internally where we are trying to figure some logic out regarding how that is possible. I hope the new figure is at least visible to everyone, or is it not?
It is. It's there.
It is. Okay. So yeah, this is what I was like. We were talking about, like, like for example, let's say if you have going back to the same logic that I was trying to talk to you about, like the ultra wideband tags that we have for indoor localization, right? So in itself, if you, let's say, turn on that tag or some person wears it on the helmet or on a jacket or whatever, it comes within a subsystem where there are anchors out there. The anchors over here imply that these are the ones that are able to, for example, communicate with these standalone tags, and then they try to aggregate this information and then send it to an MQTT broker. So over here, just replace MQTT SN with MQTT, and then you'll be able to understand where let's say the software on such nodes is able to talk on a certain radio layer. So in our case, let's say that could be Wi-Fi, that could be Ethernet, that could be Bluetooth, whatever. This then, for example, goes on, the upper space is actually like an edge device. So you can assume that an edge device runs an MQTT broker on it, where the MQTT client already has, let's say, some awareness about where to publish this information. So if they are publishing, let's say, X, Y, and Z Cartesian coordinates, then it will publish this information to the broker which is running on the edge device. So in that case, let's say if it is a Bluetooth system, then the peripheral interface is quite different. If it is a long-range LoRaWAN system, then you have to have a certain peripheral that talks that radio language, and then it converts it to something which is much more understandable by the kernel. And this kernel then, for example, let's say it can convert that data to a socket interface. So things like, it's pretty similar to like an on-whiff camera where you have something which is /dev/video1, video2, that those are the socket interfaces that the kernel provides, right? In that case, the MQTT broker, for example, provides this information on 1883 in our case, and then we can, for example, use that logic by creating whatever Akri will provide in terms of this monitoring broker that I've written in the proposal, where it itself consists of an MQTT client in it, and it can then subscribe to that topic, let's say Cartesian coordinates, and then based on that, because this information keeps publishing on that particular topic, the Akri component can then trigger some form of application that goes up that can utilize that information that is being published, and then things can happen and wonders can be created. So this is how I currently perceive it at this point of time. Of course, it might be bound to change, but it's mostly the case where everybody as an MQTT who's part of the MQTT subsystem realizes that this is how the data looks like, this is the topic that looks like. And based on this information, you can then, for example, create whatever application layers are necessary in order to consume this information from these MQTT client nodes. I hope I've made some sense.
So I think what you're saying, at least what I understood, and please let me know if that's not right.
Yeah.
So when you, in this case, add a new device, which is the helmet or sensor that's
Right.
sending the localization information, then
Right.
you go and reconfigure Akri so that it can know that you're publishing a new topic for that specific device. Is that like how it's going to work?
I think you can, so on the other, like in a way, so all the MQTT applications that I've ever written and I've ever used in my research part is a fact where a client is able to subscribe to multiple topics, right? So it can be a possibility where the developer has predefined knowledge of which topics the data needs to come into. So you can have temperature, let's say temperature barometer, X, Y, and Z things or locations already predefined in the Akri configuration. And then the MQTT client in the Akri monitoring broker will be able to subscribe to those topics, and based on that, create some form of decisions. You don't have to proactively restart things because a new, for example, topic needs to be introduced. In most cases, you can define a list of MQTT topics, and then one client is able to manage a lot of subscriptions single-handedly. That's how most of the protocol is specified.
Okay, I'm a little bit confused. So
Okay.
Let me ask maybe another clarifying question,
Yeah.
and please, anybody, please jump in. So the resource in this case is the topic. Is that true? Like the Akri resource is a topic. So an application can say, hey, I need temperature. Because I thought, like earlier you mentioned that each new sensor will have its unique topic. So I thought when you plug in a new like
Yes.
MQTT publisher, it will have a new topic. So that new topic knowledge need to be fed to Akri somehow. So which way are we going? Are we going with a new topic, but maybe the subtopic is unique, but then there's a common predefined top level topics
Right.
that Akri is aware of? Is that what you meant?
So I think the latter part, it makes complete sense. Why? Because if you go through the specifications, MQTT allows the concept of wildcard subscriptions, right? So if you are aware that this is a particular higher level topic that it looks like, you can subscribe to a wildcard topic which says, okay, everything under this topic, irrespective of how it is, it's like a regular expression match. You will eventually get the data. So let me see if I can just quickly pull up that thing in the documentation, and I think it will make it much more easier.
Okay, I think that makes sense. And will then the applications that are requesting an Akri resource, are they able to specify just the high level topics? And Akri use wildcards to get them that, or can an application be deployed to a specific, like targeted specific, let's say sensor with a specific topic?
Yeah, that's a good question. So that's the first question. That's the challenging aspect where we need to decide if each of the edge device actually receives this information from these wildcard topics, right? So chances at the first step, I think the most initial implementation would require Akri to deploy some form of application on each and every edge, because on each and every edge device, because we are not sure on which device a particular information is coming on this particular topic. yeah, that's pretty much it. Because the thing, like I think the question that I was trying to answer in the first part is we are not sure which, even if we subscribe to a topic, there's no guarantee if one of the edge devices is able to procure that form of payload on that particular topic. If something goes haywire, chances are, even though the connection is still there with that edge device, or that edge, or the broker running on that edge device, probably the data might not be coming in. So I mean, in much more of a technical way, maybe one can design a timeout mechanism which says, okay, after 120 seconds or 3 minutes, if no data is still coming in, maybe strip down the whole application that Akri is part of, and then move on to and keep the other applications running on the other edge devices. Why? Because the data is still coming in. Yeah.
So it sounds like we have, we could probably discuss this for a while. There's a lot of different details that we need to consider. I think, once again, these would be great. I know it's a lot to add, but Shannon, if you could add anything we've discussed to the proposal, that'd be great. I think we only have 8 more minutes, so I think at this point it'd be good to pass it over to Giovanni to talk about co-op. Obviously not a ton of time, and we can continue this conversation on the PR itself as well.
Okay. Hi, everyone. Sorry for being late, me too. But actually, I was not late because... so I think I would like to share my screen also. Oh, I can do it. I can do it. And let's see. Okay. I don't know what I can say in 8 minutes. It's a very low amount of time. I think that it would be very interesting to maybe discuss the issues Sean talked about in Mqtt, but on co-op perspective. And just as a general introduction of co-op, co-op is a protocol for constrained devices, and based on the idea that you want a RESTful architecture. So COP is a protocol which has been realized with this goal in mind. And in particular, so I have a slide here. The idea is that the Rust protocol has been very successful for the scaling of the internet, as we know. And although most of us, me included, associate the term Rust with a special kind of APIs of how you send requests to a server and receive the response. Actually, Rust is an architectural style which was born even before JSON, and it's more about how the different parts, the server and the clients in the web communicate in the internet. And as we know, the internet is a very large-scale system. And for instance, the COP protocol is not based on HTTP compared to usual Rust. It's based on UDP, but it follows the same behaviors. So we have a uniform interface like get, post, and so on. So we don't need to define our own methods. And that is important because, as Sean said, that I hope the pronunciation of the name is correct. Sorry if it is wrong. And as he said correctly, a pain point, especially with IoT devices, is that each device could have its own implementation, could have its own names, for example, for the topics in Mqtt, and the same goes for the resources in Rust protocol. But at least in the Rust protocol, the methods are well defined, so you don't have to invent yourself get this method or edit this parameter or so on, you have a standard method of the HTTP protocol, which are available also in COPE. And actually, in the COPE protocol, the proposal is combined with the core protocol, which means constrained RESTful environments. The core protocol is meant to solve the issue with the naming of the resources, so that instead of calling your resource, for example, temperature or temp, or maybe temperatura in Italian, you can call it as you want, but you have to support a well-known resource called well-known core, which allows you to advertise the resources to the network. And each resource, you can define, for instance, that /temperature is a resource of the type temperature, and type of the temperature has well-defined values from standard. So that the idea is that, for instance, with the Akri, you can then have an application which requires a temperature value, and the application can just ask for a device with the resource of type temperature using this standard type value, and Akri can provide any device which implements COPE and which advertises this kind of resource behind the well-known endpoint. And about the pull request itself, and I have to improve based on the feedbacks that I've received. I haven't went through all of them yet, but I think there are interesting points to be discussed. Since I had already written the implementation for the previous architecture of Akri, most of the implementation is already done. I think we needed just to discuss the architectural issues and more semantic issues, just like with the Mqtt. For instance, the question, what happens if a device goes offline, is also applicable, very much applicable to Akri. And on that, for instance, on that matter, on one of the previous meetings, I already bring up the issue. And for instance, for me, that should be something that should be discussed at the Akri level and not only on the protocol level, because it's a common issue, in my opinion, for many protocols, how to deal with a device that is losing connection. And yeah, I would have obviously more to say, but since the time is running out, that's a very short description of the COPE. Maybe in the next meeting, I will go more deeply to the details of the protocol, and for instance, about how, in my opinion, the protocol is able to, not maybe able, but at least provide some idea of a solution to the issues that Sean also has mentioned before.
I don't know if other people are strict on time, but I am comfortable going over if you are, Giovanni, because I certainly have some questions that I would love to discuss and hear your thoughts on.
Mm-hmm. I'm fine.
Okay. I think one of the things that I was wondering about with your current PR is how much of it is constrained by the template that we created for discovery handler development. So for example, like a timeout discovery loop of doing discovery of devices every 10 seconds. I remember when we were first discussing it, you mentioned that that might not be the best implementation, rather a constant kind of awaiting new devices and responding to a new device rather than an iteration every 10 seconds.
Okay. That is a very good question, and I think about the timeout is not a very big issue. I think that in general, as we add more protocols to Akri, like some Mqtt, important questions start to rise and also common questions between protocols. And for instance, about the template or how Akri works, as also mentioned before, for me, the fact that right now, Akri considers each device to be associated with a node. And on that topic, I think for COPE, it doesn't make much sense because, and also that this issue is in common with Mqtt because with both Mqtt and COPE, we have IoT devices which are not associated with any specific machine. They are independent, and so by having instead an agent deployed to each node and each node trying to discover a device per node, I think that kind of behavior doesn't make a lot of sense to COPE. For instance, in my case, I remember that I had an issue because I had one device implementing COPE, and then in my cluster I had, I think, 3 worker nodes. So I had 3 agents on each, on each node, and they were, I could say, bombing the single device with discovery requests. And for instance, every 5 seconds or every 10 seconds. But the timeout question, I think, is of secondary importance. The issue was that each one of them was sending a request to the COPE device, and which was not able to maybe answer that many requests because it's a very, very much constrained device. And especially, I mean, with the free, it's also accepted. Actually, in the end, I was able to solve the issue. But if you have a real world cluster of maybe 100 nodes, that will become a very important issue.
So it sounds like with COPE, it would be ideal to have the agent and the discovery handler running on only one node.
Yeah, maybe one node, or maybe a limited number. Maybe you could have horizontal scaling for the agents, but surely not per node. And yeah, that's it. And also another issue, like we already mentioned several times, is that I would like to advertise the resources. What's important for COPE are advertises the resources by the device, not the device itself, the hardware itself. That is not important. Just like with Mqtt, what is important is the topic, not actually the device. I will, as Sean said, I would also wanted to have COPE devices pushing data to the cluster, the Kubernetes cluster, so the application can leverage this kind of data for any kind of application. That is the main goal also to the to COPE. So that it's just that, in my opinion, code is more scalable and standard than Mqtt, and that's why I chose it for my purposes.
That makes sense. And I think for the way the agent is deployed, is there a better strategy you see than adding a node selector to the deployment YAML for the agent? So for example, say you wanted to deploy the agent just to one node, you could add a node selector for that node.
I think that to answer this question, it's important for me to explain a bit the context of my use case, which is the idea that in my case, I don't imagine developers configuring the Kubernetes environment to deploy a custom-made application and to have this very hard-coded, also application connected to some well-known devices. it's not like a local Kubernetes cluster. I would like to have this system working on as a service environment, just like Azure. So in that case, you cannot you don't know how which node selector to apply to your node, because you want, for instance, to offer on Azure the ability to deploy any kind of application which require some kind of sensor information. So for instance, if you wanted to deploy Azure applications on the edge, just like today, you can do it on the cloud. You can say on today's application that you want a database service, but on the edge, you may also want some data service, like a temperature service, so that you can deploy your, for instance, weather service on top of it on the Azure infrastructure. And you want also, of course, people to pay for this kind of a service. But as everything is automated, you cannot, you don't know which kind of node selector or this kind of decisions to make. Everything should be done by machines and in a machine-to-machine communication. And that is also why COPE and protocols like Core are very important for my use case. Because if you needed to decide the node selector or any kind of specific parameter, then you're not able to scale it, even on a local use case where you have, for instance, hundreds of devices, or just like Sean said before, you have 10 devices today, and then tomorrow you have another 10 devices, and you need to configure again the Akri, the template or so, and you need to deploy again. That is not feasible for many cases to change the configuration just because new devices are added or a new application needs to be deployed. So that is also why I think that maybe we should open an issue or more issue and discuss more about it, maybe on by writing our ideas with more time, maybe, instead of just having a conversation. Well, I usually forget everything we said in the meeting 1 hour later.
Yeah, so to clarify, the issue would be discussing where the agent is deployed and how to advertise discovered devices to nodes that aren't necessarily, that don't have a discovery handler on them. Is that kind of the issue you're interested in?
I think we have a different issue to tackle. Yes, this is the right one. Yes, this is, I think, one of them. And the other one is how do we allow to define resources which are not hardware, but more software, more just like data, like COPE resources and Mqtt topics.
And that's the issue around that, is because these resources have, this device has more than one resource it's advertising.
It's not just, I don't think it's just like an issue of number. It's more issue, I think, of how.
I think this is much more architecture oriented. I think what Giovanni
exactly
is the fact that I mean, in terms of in the context of Akri, it makes absolute sense if you have, let's say, a USB camera that the edge device directly can mount it on. But in a lot of different industrial scenarios, things like these are not possible at all. So they have a different, so to say, subsystem, but they are able to talk a certain common language, which is like, for example, CoAP or Mqtt. And there are, let's say, paradigms there, like things like PubSub and then request response things, which generally don't have an assumption that this thing actually runs on the hardware itself, right? So it is like a, how do you call it? It's like a decoupling concept of because of the architecture and the protocols that these technologies speak. So That should be an issue in itself on how do we try to solve this part.
Yeah, I agree. I completely agree. That is just not an issue about the number of devices or so. It's more about how Akri, I would say, not specifically how Akri works, but how Akri thinks the edge environment works. Because as Sean said, in industrial applications or even other kinds of environments, you don't have USB devices for each node or something like that. You have a completely different kind of scenarios. And I think there is an issue with Akri that it has the wrong assumption about the environment itself, not just a technical issue about how many devices or resources. That is just a consequence for me.
Yeah, I think it'd be interesting to open the issue and maybe discuss how what your the architecture that you're describing differs from what we currently support with ONVIF, yes. Because that isn't coupled to an edge device. And so discussing how the needs of co-op and Mqtt differ from the needs of ONVIF would be interesting in that discussion too.
Yeah.
So yeah, Giovanni, if you'd be willing to create those issues, that would be great. And we can move this discussion to there. And then also on the PRs, there's obviously a lot of topics that we've covered today and exciting new implementations for Akri and also discussions about where Akri should go. So are there any last questions or comments? I know we went a little over. Awesome. Well, thank you everyone for joining. This has been great. And we'll put the recording from this up in the Slack probably in a week. And then we'll see everyone in a month from now.
Thanks all. Talk to you later.
Bye-bye.
Thank you. Bye-bye.
Bye.
Bye-bye, everyone.